Hi, my name is Dushyant and I'm giving a presentation on classifying Alzheimer's disease based on complex graph measures and machine learning techniques. What is Alzheimer's disease? Alzheimer's disease is a neurodegenerative disease characterized by progressive dementia. It's one of the seventh leading cause of death in the United States. The current knowledge of the Alzheimer is very limited. Also, there is no proper clinical diagnosis for the disease, though it is present only through autopsy. And also, there is no proper cure for this disease. So, what my project does is it seeks to evaluate the critical brain regions and their connectivity patterns that can aid in diagnosing Alzheimer's disease. I got a data for 45 patients, and 15 suffering from Alzheimer's, 15 the healthy patients, and the 15 which is a stage in between Alzheimer's and an healthy subject. So I got these data as a DTI images. So I pre-processed using tractography and represented it as a connectivity matrix. So I got the data of a Broadman areas. So there are a total of 41 Broadman regions. There's the data. There are a total of 45 samples. MC represents the stage in between the Alzheimer's and the healthy subjects. CT are the controls, those are the healthy subjects, and the AD are the patients suffering from Alzheimer's. There's the data. It's a 41 cross 41 connectivity matrix, but each cell represents a broad area. A value of 0 represents that there is no connection between the respective brain regions, and a value represents the magnitude or the intensity of the connection between those brain regions. Once these data were processed, I use a graph technique using a graph tool to convert these connectivity matrix into a graph, where in a graph each brain region was represented as a node and the edge represents the connectivity between these brain regions. So I use graph tool. There's a code create graph in order to convert the connectivity matrix to a graph. I have coded it using Python. There are a total of 41 vertices. Once the graph was created, I used a centrality measures in order to extract the features from a graph. A centrality measure is one which finds the most important node in a graph. I use 10 different centrality measures in order to extract the features. The different centrality measures that I use were the closeness centrality, the betweenness centrality, cat centrality, hedge centrality, eigenvector centrality, the degree centrality, clustering coefficient centrality, the page rank centrality, and the hub centrality. So these graph measures were applied on the graph in order to extract the features there. So there were 10 different graph measures and 41 nodes, so a total of 410 features were extracted. This was the final data that I obtained. Initially I did a multi-class classification where the labels were AD, CT and MC. Since I was more concerned with the classification between AD and CT, I did a binomial classification. So there are 15 samples each of AD and CT, so there were 30 samples and a total of 410 features. Since the sample size was very less compared to the number of features, I used a feature selection algorithm. Feature selection is one of the famous machine learning technique that finds a subset of features from a given feature set. So it extracts the relevant features, removing all the irrelevant and the redundant features. The feature selection technique that I used was the weight by rule feature selection technique. Weight by rule feature selection technique assigns weight to each of the attributes based on the label attribute. So at last, once the feature selection algorithm has been applied, the output is the weights. The higher the weights, the more relevant are the features. Initially, I coded both with the Python using scikit-learn as well as I have used RapidMiner. This is a code which I used in scikit-learn where I use the tree classifier, the forest trees classifier as a feature selection technique, and the decision trees classifier for the classification. What's a decision tree? A decision tree is one of the classification algorithm that is used in machine learning. So it tries to classify a given sample where each node will be represented as a feature and the leaf is represented as a label. This is a pictorial representation where the root node, based on the attribute value, it branches to the leaf node, and at last the leaf node is the possible answer. And I have used one of the cross validation technique called a leave one out cross validation technique, where in a given sample size n minus 1 samples will be treated as a training set and the remaining one sample will be treated as a testing set, and this will be repeated for as many number of sample size. So I've coded both in the scikit-learn as well as using RapidMiner. Since I don't have a Python installed in my system, I'll be showing you the code using the RapidMiner. I've done both the feature selection as well as the classification inside the cross validation, where I've used leave one out validation. This is the data with AD versus the controls. This is the weight by rule feature selection technique, and this is the select by weight. It selects the weights based on the threshold. So whatever the threshold that I give you, so only those features, subset of features with the weight greater than these values will be selected. So using this technique, I achieved a classification accuracy of 86%. That is a max accuracy that I achieved using a classification using feature selection threshold of 0.7. These were the results that I obtained. I obtained a classification accuracy of 86% for AD versus MC with a feature selection threshold of 0.7. So a total of 193 features were selected during the classification, and the precision and recall for predicting AD were 82 and 93%, and for predicting MC were 92 and 80%. These were the Broadman areas that were selected. Broadman areas 31, 3, 5, 7, 9, 11 and 17, along with the centrality measure. This was between a centrality measure and the clustering coefficient centrality measures. And also I observed a classification accuracy of 76% for AD versus CT with a feature selection threshold of 0.8%. So a total of 185 features were selected during the classifications, and the precision and recall for predicting AD were 83%, 66%, and for predicting CT were 72 and 86% respectively. And these were the list of features that were selected during our classification process. This is a graph that shows the classification accuracy versus the feature selection threshold for the AD versus CT, where the x-axis represents the feature selection threshold and the y-axis represents the classification accuracy. So I got a maximum accuracy for 0.8 feature selection threshold with a classification accuracy of 76.7 classification accuracy. This is a graph which represents the classification accuracy versus the feature selection threshold for AD versus the MC. It is same as that of the previous, representing the x-axis and the y-axis. I achieved a maximum classification accuracy of 86.71 with the feature selection threshold of 0.7. I've included both the codes, the RapidMiner code as well as the the scikit code for the classifications. This is the main thing, and these two are both the classification for AD versus MC and AD versus the CT. I've used Leeuwenhoek classification. These are the results that were obtained as I have told you earlier. So what's the conclusion from the above project? Whatever the results that I obtained shows that complex graph measures and machine learning technique can be efficiently used to diagnose Alzheimer's disease. Also, the result shows that the disease affects more broad areas and temporal lobe where there is a decline in connectivity. Since the sample size is very less, so I plan to increase the classification accuracy. Also, to find more accurately affected area by Alzheimer's disease, I plan to perform the further analysis with different methods for feature selection, also on a very large data set. Thank you. Thank you.